Bismillah ar-Rahman ar-Rahim. In the name of God, the most gracious, the most merciful, welcome to Lady Khadija radiallahu anha. May God be pleased with her online college. This is Year 2 A-Level Maths live lesson. We're working through the chapter on parametric equations. So far, you've covered all the skills you need to know, and now you want to apply that to what can be called a real-life type scenario, also known as modeling, but really it's just a word problem. So there's no need to panic. It's just a word problem. If you can translate the words into the maths questions you need to answer, then you'll be fine. Let's begin. Bismillah ar-Rahman ar-Rahim. In the name of God, the most gracious, the most merciful. A plane's position, this is an aeroplane's position t seconds after takeoff can be seen by the two following equations. The x, so that's the distance it's traveled across horizontally, can be worked out by v cos theta times t. T is the t seconds after takeoff, v is the speed of the plane, and theta is the angle of takeoff. Y is equal to so y, that's the y coordinate of the plane's position, is equal to, or that's the height above the ground, is equal to v sine theta times t. Then the information you're given is that when the plane travels 600 meters horizontally, that corresponds to it having climbed 120 meters. So based on that, the first part is to find theta. Okay, so let's imagine here's your plane and it's gone 600 meters horizontally. If you just draw that as a straight line going across, and that's 600 meters, and then that's 120 meters vertically. And if we just join those two, the beginning and the end, that's a right angle triangle. It's 600 across, it's 120 up, and the theta is the angle of takeoff, which is this one here. So see if you can think of how to work out the theta. It's GCSE maths, sine, cos, and tan. Hopefully you can guess we're going to need tan, so we can say tan theta is equal to, and if you remember the formula for tan theta, it's opposite over adjacent. Opposite over adjacent. In this case, the opposite will be 120, and the adjacent will be 600. So you can take the 120 and put that in place of the opposite, and you can take the 600 and that's in place of the adjacent. And then if you inverse tan that on your calculator, then you should get theta. I'll give you a second to do that. Is equal to 11.3, and I've just rounded that to write that down, but you should be working with the full number, whatever it is on your calculator. So that theta is 11.3. Now we need to find the parametric equations. It's given us the speed is 50, so that 50 is the speed, and that's your v in the parametric equations here and here. So let's write out those parametric equations with 50. So I'll have x is equal to 50 in brackets 50 cos theta. Theta, you can put in the 11.3 from before, times t. That's 50 sine theta. Theta we know is 11.3 times t. Okay, and that's it. That's how we can take a word problem and then put in the right numbers and work out the parametric equations. There is more on this question, which we can take a look at in our next lesson. Assalamu alaikum wa rahmatullahi wa barakatuh. Peace be with you and the mercy and blessings of God.